Welcome back to the Deep Dive. Today, we're not just talking about a software update. We aren't just looking at a new feature or, scrolling through a changelog.
No, not at all.
We are looking at a blueprint. And frankly, this might be one of the most important blueprints you look at if you're working in the cloud right now.
It really is. It's a fundamental shift. It's the difference between, let's say, improvising and actually engineering a solution.
Right. And the source we're digging into is titled The Bedrock Blueprint, Architecting Generative AI on AWS. Just that title alone, The Bedrock Blueprint, it sounds so substantial, doesn't it?
It does. Foundational.
Yeah, foundational implies that, the ground has finally settled enough for us to start building some permanent structures on it.
That is exactly the word I would use, foundational. Because for the last, year and a half, we've seen this absolute explosion of generative AI, right?
Total chaos.
Total chaos. Everyone is playing with chatbots. Everyone is generating images. Everyone is doing the hello world equivalent of AI. But the conversation has really moved on.
It had to.
It shifted from, wow, look at this magic trick, to, okay, how do we actually build this into a reliable enterprise system that doesn't hallucinate all over the place, doesn't cost a fortune, and is actually secure? And that is where architecture comes in.
That's where the blueprint matters.
Exactly.
And the mission for this deep dive, which we're pulling straight from our source material, is very specific. The goal is to, and I quote, internalize the AWS generative AI building blocks.
Internalize. I love that word choice.
Right. It's not just learn or memorize. It's internalize.
And there is a huge difference. I mean, memorizing is knowing the names of the services so you can, I don't know, pass a certification exam.
Sure, ticking the boxes.
Internalizing is having an instinct. It means that when you're sitting in a meeting and a stakeholder says, we need to build a search tool for our legal contracts, your brain immediately fires the synapse for a vector database and knowledge base.
You don't have to go look it up.
You don't. You know the shape of the solution because you understand the materials you're building with. You know how they fit together.
So the idea is that by the end of this, when you're faced with a new problem, say building a customer service bot or a code assistant, you shouldn't be playing a guessing game.
No.
You shouldn't be wondering, okay, do I use SageMaker for this? Do I use Bedrock? What about Kendra? Do we need that Lambda function here? The answer should feel natural.
That is the mark of a true architect, isn't it? It's about understanding the relationships between the services. It's not just knowing what each Lego brick does.
Right.
It's knowing which bricks snap together to build the castle you're actually trying to build. And this source material, this Bedrock blueprint, it basically lays out the entire kit for us. It shows us exactly what pieces we have on the table.
Okay, so let's give everyone a high-level map of where we're going today. We are going to start at the center, the absolute core of this blueprint, which is Amazon Bedrock.
The centerpiece, for sure.
Then, from there, we're going to tackle what I think is maybe the most confusing part for a lot of people. The great divide. Bedrock versus SageMaker.
Oh, that is crucial. I mean, if you get that wrong at the start of a project, you are in for a world of pain and, frankly, expense.
A lot of expense. We'll make sure you don't get that wrong. Then we will look at the supporting cast, all the other services, the vector databases, the search tools, things like Amazon Q.
The whole ecosystem around it.
And finally, and this is the part I'm most excited about, we're going to do exactly what the source suggests. We're going to sketch out some reference architectures. We're going to mentally draw on the whiteboard.
Yes, that's where the rubber meets the road. It's one thing to talk about it, another to actually design it.
So yeah, buckle up. We are diving into the Lego set of AI.
Let's do it.
Okay, so let's unpack section 1, the core. The source, as we said, places Amazon Bedrock right at the center of the solution. Now, when I hear Bedrock, I mean, my first thought is geology. Solid rock. Why? Why this name, and why is it really the center of this new universe?
Well, think about what Bedrock actually does in geology. It's the solid, stable layer that everything else sits on top of.
Foundation.
Exactly. In the AWS ecosystem, Amazon Bedrock has become the primary consumption layer for generative AI. The source describes it explicitly as the place for FM consumption and orchestration.
FM, of course, standing for foundation models.
Correct. And the most important word in that phrase is consumption. Before Bedrock, if you wanted to use one of these massive language models, you often had to manage the infrastructure yourself.
Right, you were spinning up servers.
You were worrying about the servers, the GPUs, the scaling, the patching. You were basically a plumber just to get a glass of water. Bedrock abstracts all of that away. It is, at its core, an API. You are not managing the model's server, you're just calling the model. You're consuming it as a service.
So it's the access point. It's the front door to all this power.
It is the universal adapter. And what truly makes it the centerpiece, as the source notes, is that it gives you access to multiple model providers through that single API. It's not just Amazon's own models.
Yeah, the source lists model providers as a key concept within Bedrock.
This is so interesting to me because usually big tech companies want you to use their stuff exclusively. But Bedrock is saying, hey, you want to use Anthropic's Claude, you want to use Cohere, you want to use AI 21 Labs, or maybe you want to use Amazon's own Titan models. They're all there.
They're all in the same catalog, behind the same API. And that is the real power of it. It's model agnosticism.
Which, as an architect, that's freedom.
It's massive. As an architect, you do not want to be locked into one specific model because this field is moving so incredibly fast. The best, most capable model today might be second or third best in 6 months.
Or 6 weeks. Or 6 weeks, honestly. If you hard-code your application to specifically use, say, OpenAI's API or to run a Llama model on a dedicated server you manage, switching that out is a whole project.
It's a rewrite.
It's a rewrite. With Bedrock, switching your application from using Claude 3 Sonnet to, say, Amazon Titan might be a single line change in your configuration file. That's it. Bedrock lets you swap them out without re-architecting your entire application.
That is huge. I mean, that's just fundamental future-proofing for your entire system.
It is. It lets you focus on the business problem, not the underlying model specifics.
Okay, so that's the models. But the source also gets specific about modalities. We're not just talking about text anymore.
No, and this is where it gets really interesting for building rich, complex applications. The source explicitly calls out text, image, and embeddings.
So text is obvious. That's the chatbots, the summarizers, we all get that.
Yeah.
And images, we know that too. That's generating a picture of an astronaut riding a horse on Mars.
The classic example.
But let's pause on that third one. Embeddings. The source highlights this as its own distinct capability. I feel like this is a term that gets thrown around a lot in technical meetings, and everyone just kind of nods along. But what is Bedrock actually doing here? What is an embedding?
I'm so glad you're focusing on this because it is the unsung hero of applied generative AI. An embedding is basically a translation. You take a piece of text, a sentence, a paragraph, an entire document, and you feed it to a special type of model.
An embedding.
An embeddings model, exactly. And instead of talking back to you, it turns that text into a long list of numbers. A vector.
Just numbers.
Purely numbers. It might be, 1,536 numbers long. But here's the magic. Those numbers represent the semantic meaning of the text.
The meaning, not the words.
Precisely. So if you have a sentence about dogs and another sentence about puppies, their embedding vectors, their lists of numbers, will be very close to each other in that mathematical space. But if you have a sentence about dogs and a sentence about quarterly financial reports, their vectors will be very, very far apart.
So Bedrock has these specific models that are designed not to talk to you, but to turn your company's documents into math.
Exactly. And that math is what allows you to search through millions of documents instantly to find the most relevant information based on concepts and ideas, not just keywords. This is the foundation of R, which we'll get to later. So yeah, that embeddings modality the source talks about, it is absolutely critical for almost every serious architectural pattern.
Okay, that clarifies a lot. So we have the models, we have text, image, embeddings. But the source material goes a step further, talks about what it calls the smart layers.
Yes.
Specifically agents and knowledge bases.
This is where we move from just, generating text to actually building a complete functioning application inside the Bedrock ecosystem.
Let's start with knowledge bases. What problem is this solving? What is Bedrock adding here?
Well, a standard foundation model, let's say Claude or Titan, it only knows what it was trained on. And that training data is frozen at a specific point in the past.
Right. It doesn't know what happened yesterday.
It doesn't know about your company's new internal HR policy that you updated yesterday morning. It doesn't know your Q3 sales data. It has no access to your private proprietary information.
So it either hallucinates an answer or just says, I'm sorry, I don't know. The classic confident liar.
Exactly. A knowledge base for Amazon Bedrock is a managed service where you point Bedrock at your data, your PDFs, your Word documents, your web pages on S3, and it automatically handles that whole embedding process we just talked about.
Oh, so it automates that translation to math.
It automates the whole pipeline. It reads your documents, breaks them into chunks, creates the embeddings, and stores them in a vector database for you. It connects the brain, which is the model, to a library, which is your data.
So instead of me having to build a complex system to orchestrate all that, the chunking, the embedding, the database storage Bedrock just says, point me to the S3 bucket, I'll handle the rest.
Precisely. It simplifies the architecture significantly. It turns what we call retrieval augmented generation, or RAG-I, into a managed service. It turns an open book test for the AI into a feature you can just turn on.
Wow. Okay, that's knowledge bases. What about agents? The name sounds like something out of a spy movie. Bedrock agents.
It is a bit like spycraft, actually. Or maybe a better analogy is having a very, very capable executive assistant. If a knowledge base helps the model know things, an agent helps the model do things.
Do things, as in take actions.
Yes. Take actions in other systems. Think about a standard chatbot. You can say, book me a flight from New York to London. The chatbot will come back and say, sure, I have generated some text for you about the steps to book a flight.
Right, it can't actually go into the airline system and book it.
Yeah.
It's trapped inside the text box.
It's just words. An agent for Bedrock allows you to give the model a set of tools. And these tools are your APIs, your Lambda functions, your code.
So you're giving it arms and legs.
You are. So when you say, book me a flight, the Bedrock agent understands the intent, it looks at the tools you've given it, figures out it needs to call your book flight API, it gathers the necessary parameters like date and destination, executes the code, gets a confirmation, and then comes back and says, okay, your flight is booked, here's your confirmation number.
That is a complete game changer.
It is.
That changes it from a fancy typewriter to a virtual employee.
That is the perfect analogy. It transforms the AI from a passive text generator into an active participant in your business workflows. It can update a Salesforce record, query a database, or send an email. It bridges the gap between conversation and action.
Okay, now before we move off Bedrock, the source is a very practical note. It specifically suggests that we should all explore the Bedrock console and mock up a few calls. Why is that specifically called out? Why not just read the documentation?
Because there is a tactile, intuitive difference between reading about a parameter and actually tweaking it yourself. The Bedrock console is a playground. It's a laboratory. You can go in there, select a model from a drop-down Claude Titan Llama type in a prompt, and see the result instantly. But more than that, you can play with the knobs. You can change the temperature, which controls how creative or, random the model is, and see how the output changes from factual to poetic.
It's like the difference between reading a recipe and actually tasting the soup as you're cooking it.
Yeah.
You add a bit of salt, you taste it. A bit more pepper, taste it again.
Exactly. And the source mentions mocking up calls for both text generation and embeddings. Seeing an embedding vector with your own eyes, seeing that giant wall of numbers appear on your screen after you input a sentence, it makes the whole concept real.
It demystifies it.
It totally demystifies the magic. You realize, oh, this is just data. It's a list of floating point numbers. It's not some unknowable dark art. And that hands-on experience is invaluable for an architect.
I love that. Demystifying the magic. That's really what we're here for. Okay, so we've established Bedrock is the center. It's the consumption layer. It's the playground. But now we have to address the elephant in the room, or maybe the other 800-pound gorilla in the AWS AI room.
SageMaker.
SageMaker. Section 2 of our outline, the Great Divide, Bedrock versus SageMaker. The source explicitly positions this as a comparison we absolutely need to understand.
This is probably the #1 question I hear from teams who are just starting out. We want to do AI on AWS. Do we use SageMaker or do we use Bedrock? It's the classic fork in the road right at the beginning of the journey.
And if you take the wrong path.
It can cost you a lot of time and money, but the source gives us a very clear, very distinct line in the sand.
Okay, let's hear it. What's the dividing line?
It says Bedrock is for FM consumption and orchestration, and SageMaker is for custom training fine-tuned deployments.
Okay, let's really unpack that. Consumption versus training.
Think of it like this. If you want to drive a car, you have 2 basic choices. You can go to a rental agency, look at their fleet, pick a sedan or an SUV or a convertible, get the keys, and just drive. That's Bedrock.
Yeah, man.
You are consuming a car that already exists. You didn't build the engine. You didn't assemble the chassis. You didn't design the transmission. You're just using it.
The finished product. And SageMaker.
SageMaker is for The person who wants to build a custom race car from scratch in their garage. They want to bore out the cylinders, they want to tune the fuel injection map themselves, they want to choose the gear ratios, they want to control every single aspect of the engine's performance.
They're the manufacturer.
They're the manufacturer, or at least the heavy customizer. They're buying the raw parts and building the machine themselves.
So SageMaker is for when the off-the-shelf models in Bedrock just aren't good enough, or when you need to do something really specific.
Specific is the perfect word, or highly proprietary. Let's imagine you're a medical research company and you have a proprietary language for describing molecular structures that absolutely no public model has ever seen or understands.
Right, Claude or Titan would have no idea what you're talking about.
None at all. In that case, you might need to take an open source model like Llama and fundamentally change how it thinks by showing it millions of your own specialized documents in a heavy custom training run. That is SageMaker territory.
It sounds like SageMaker's a lot more work.
It is exponentially more work, and it's more responsibility. When you use Bedrock, AWS handles the infrastructure, the scaling, the availability. It's serverless.
You just pay for the call.
You pay per token, basically. When you deploy a model on SageMaker, you are managing the endpoints. You're choosing the instance types. You're managing the scaling policies. You have full granular control, but you also have the full burden of managing that infrastructure. You're paying for those instances to be running 24/7, whether you're using them or not, unless you configure auto-scaling perfectly.
So if we're following this blueprint, the default starting point, the main road, seems to be Bedrock.
Absolutely. The rule of thumb the source implies is start with Bedrock, always. Try to solve your problem by consuming the existing models. Try to fix it with better prompting, what we call prompt engineering. Try to fix it by giving it more context, using a knowledge base and RAG.
Exhaust those options first.
Exhaust all the consumption-based options, only if that fails, only if you hit a hard wall where the model simply cannot learn or perform the task you need it to know. Then you look across the road to the custom garage, which is SageMaker.
Don't go build a custom engine if all you need to do is drive to the grocery store.
That's it, exactly. It's the classic AWS principle. Avoid undifferentiated heavy lifting. Managing model infrastructure is heavy lifting that, for most use cases, you no longer need to do.
But the source does mention a hybrid Bedrock plus SageMaker pattern, so it's not always an either choice. They can work together.
They can, and this is a more advanced, sophisticated pattern. Imagine you do have that need for a very specialized model. Maybe one that's really good at detecting fraud in your company's specific transaction logs.
Okay.
You do the hard custom training work in SageMaker because you need that unique custom brain. But then you want your application developers to be able to access that model through the same simple, unified API they use for everything else.
You want it to feel like just another model in the Bedrock catalog.
Exactly. And AWS is making it easier and easier to expose those custom SageMaker models so they feel like part of the broader Bedrock ecosystem. Or, another pattern, you could use Bedrock for the main conversational interface, but a Bedrock agent calls out to a SageMaker model for one specific, highly specialized prediction task.
So the architect's job is really to know when to rent, when to build, and when to connect the rental to the custom build.
Yes, and to know that building is expensive, it's time-consuming, and it requires a very different skill set data scientists, ML Ops engineers. It's a much bigger commitment.
Okay, that clarifies the core engine room perfectly. We have Bedrock for consumption, SageMaker for construction. Now let's look at the rest of the house that this blueprint describes. Section 3, the supporting cast.
The ecosystem. This is what makes the brain useful.
The source lists a bunch of services here. Amazon Q, Kendra, Aurora, OpenSearch, DynamoDB, S3. At first glance, it feels like a bit of a laundry list, but I know it's not random. How should we categorize these in our minds?
They are definitely not random. These services provide the memory and the context for the AI. If Bedrock is the powerful but amnesiac brain, these services are the long-term memory, the filing cabinets, the reference library, and the scratchpad.
Let's start with the one that's been getting a lot of hype lately, Amazon Q. The source is careful to mention two distinct types, Amazon Q Developer and Amazon Q Business.
Right, and the names give it away, but it's important to be specific about their roles in the blueprint. Amazon Q Developer is the tool for the builders, for us.
For the people listening to this.
Exactly. It lives in your IDE, your code editor. It helps you write code faster. It explains what a block of legacy code does. It helps you debug errors. It can even help you with big tasks like upgrading from Java 8 to Java 17. It is an AI assistant for the person building the software.
Okay, so that's for the techies. What about Q Business?
Q Business is for the end users in an enterprise. It's a turnkey application that connects to all your company's internal data sources, your wikis, your Slack channels, your documents, your code repositories, and it acts as an expert on your business.
So you can ask it questions.
You can ask it, how do I apply for parental leave? Or what were our sales figures in the EMEA region for Q3? And it answers based on your internal private data with citations.
So Q is basically a pre-packaged, ready-to-go GenAI application that AWS built so you don't have to.
Yes. And that is a really important distinction for an architect to make. Sometimes the best architecture is don't build it yourself. If Amazon Q Business solves 80% of your problem, if what you really need is a chat interface over your company's documents, you don't need to go build a complex Argy solution from scratch on Bedrock. You just subscribe to and configure Q Business.
Ah, that is a great point. The best code is no code. The simplest architecture is the one you don't have to build.
Correct. It's the ultimate buy versus build decision, and Q represents the buy option.
But let's say we are building. Let's say we have a custom need. The source lists Amazon Kendra. Where does that fit into our custom-built architecture?
Kendra is a highly intelligent enterprise cloud search service. It's important to remember that before the whole generative AI boom, Kendra was already there, using machine learning to understand natural language search queries.
It's more than just keyword matching.
Much more. In the context of this blueprint, Kendra is often used as the retrieval component in a RAG system. It's the super smart librarian.
It finds the documents for Bedrock to read.
Precisely. You ask a question. Kendra, with its deep understanding of language, finds the most relevant paragraphs from millions of documents, and then it hands just those relevant snippets to Bedrock to synthesize into a final answer. It's a high-end, premium search engine that handles a lot of the complexity of indexing and relevance ranking for you.
Okay, now let's get into the database weeds. This is where it gets really interesting. The source mentions Aurora with PG vector and OpenSearch service with vector search.
Yeah.
We keep hearing this word vector. We talked about embeddings earlier, that process of converting text to numbers. I'm assuming this is where those numbers live.
You nailed it. It's one thing to generate those embeddings, those long lists of numbers, but you have to store them somewhere. And you can't just store them in a standard spreadsheet or a traditional database column and expect it to work.
Why not?
Because you need a database that knows how to do math on them. You need to be able to ask the database a very special kind of question. Find me the row where the numbers in this column are mathematically closest to the list of numbers from my query. It's called a nearest neighbor search. It's finding the most similar items in a high-dimensional space.
And that's what vector search is.
That's vector search. And that's what PG Vector does for Aurora. Aurora is a standard relational database. It's PostgreSQL compatible, which millions of developers already know and use.
Right.
PG Vector is an open source extension that you can enable on Aurora, and it basically teaches your familiar Postgres database how to store and search these vectors. This is huge for architects because it means you don't have to introduce a brand new niche specialized vector database into your stack.
Yeah.
You can use the database you already know and love.
That is very comforting. It keeps the technology stack simpler and reduces the learning curve.
Massively. And what about OpenSearch?
OpenSearch is a search engine at its core. It's descended from Elasticsearch. It's designed for massive scale, for logging, for full-text search. Adding vector search capabilities to it makes it an absolute powerhouse for what we call hybrid search. Hybrid search, what's that?
That's when you want to combine the old world with the new world. You want to match exact keywords, like a product SKU, model X500, and you want to match on semantic, meaning like powerful machines that are good at cleaning floors. OpenSearch is fantastic at combining those two strategies in a single query to get the absolute best result.
So these are the different kinds of libraries where the brain, Bedrock, goes to look things up.
Yes. And it's critical to remember, Bedrock itself doesn't remember your data. It has no memory. Aurora with PG Vector, OpenSearch, Kendra, they remember your data for it.
And finally, in this section, the source lists the utility players, DynamoDB and S3.
The foundational workhorses of AWS.
Where do they fit in?
S3 is almost always the starting point. It's where the raw data lives, the PDFs, the images, the transcripts, the raw text files. Before you can index anything, before you can create an embedding, the source document has to sit somewhere. That's S3. It's the data lake.
The ultimate source of truth. And DynamoDB.
DynamoDB is your fast, flexible, NoSQL storage. In a Gen AI application, its most common use case is probably storing the conversation history.
Ah, so the bot remembers what I said 5 minutes ago in our conversation.
Exactly. The foundation models themselves are stateless. This is a key concept. A model like Claude forgets you the absolute moment it finishes sending its answer. It has total amnesia.
Every API call is a brand new conversation.
Completely new. If you want a continuous stateful conversation, you, the application builder, have to save the back and forth, the user's question, the AI's answer somewhere. Then, with the user's next question, you have to feed the relevant history back into the prompt. DynamoDB is perfect for storing that history because it's incredibly fast at reading and writing that kind of data.
Okay, this is coming together. We have the core engine, Bedrock, the alternative custom engine, SageMaker, and the supporting cast of databases and search tools that provide memory and context.
That's a whole toolkit.
Now, Section 4, Architectural Patterns. The source says how to build. It lists 4 common patterns. Let's walk through them because this is how you combine the pieces.
These are the standard plays in the Architect's playbook. Once you understand these 4, you can solve probably 90% of the use cases you'll encounter.
Okay, pattern 1, direct FM calls.
This is the hello world of generative AI. It's the simplest possible pattern. You write a script or an application, you send a prompt directly to a Bedrock model, tell me a joke, or summarize this paragraph of text that I'm including in the API call.
And Bedrock sends back the text.
And Bedrock sends back the text. That's it. Simple.
But still useful, right?
Absolutely useful. If your entire application is just a little box where a user can paste in a long article and get a 3 bullet point summary, this is all you need. No database, no vectors, no agents, just input model output.
Okay. Simple and effective. Pattern 2, Bedrock agents. We touched on this, but let's frame it as a pattern.
Right. This is the delegator pattern. The user has a complex goal that requires more than just generating text. The architecture here involves using the Bedrock agent service to orchestrate a series of steps.
It's the conductor of the orchestra.
Perfect analogy. The agent breaks down the user's request, find my top 5 customers in the UK and email them a summary. It figures out it needs to call a Lambda function to query a database, then maybe another function to format the data, and a final one to call an email API. The pattern here is about action and multi-step reasoning. It's not just talking, it's doing work.
Got it. Now pattern 3, RAG with knowledge bases. This is the big one, the big buzzword, retrieval augmented generation.
This is the bread and butter of enterprise AI today, RAG. If you're building an internal-facing AI tool, chances are you're building a RAG system.
So explain it like I'm 5, or okay, maybe 12.
Okay, imagine you're a student taking a history test. A direct FM call, which was pattern 1, is like taking the test from memory, closed book. If you studied and you happen to know the answer, great. If you didn't, you either fail that question or you make something up, you hallucinate. RAG, pattern 3, is an open book test. Before you answer the question on the test, you're allowed to go to the textbook, which is your knowledge base or your vector database. You find the exact page that talks about the topic, and you quickly read that page for context, and then you write your answer.
That is a perfect analogy. The answers are going to be so much better.
So much better, and grounded in facts from your source material. So the architecture is users question search tool, like a knowledge base, retrieve relevant documents, send documents, plus original question to Bedrock, get a fact-based answer.
And the source emphasizes R with knowledge bases.
Yeah.
Specifically because AWS has wrapped that whole complicated workflow into a single managed service.
Exactly. You don't have to manually wire together the search tool and the retrieval logic and the prompt formatting if you use the Bedrock knowledge base feature. It handles the plumbing of the open book test for you.
And finally, pattern 4, hybrid Bedrock plus SageMaker.
We discussed this distinction earlier, but as a pattern, this is the best of both worlds approach. You use Bedrock for all the general purpose tasks, summarization, conversation, creative writing, because the models there are great and it's easy to use.
Yeah.
But you have that one special custom trained model on SageMaker for your proprietary task. The pattern is about integrating them. Your main application talks to Bedrock, and a Bedrock agent, when needed, makes a call out to the SageMaker endpoint to get that one specific custom prediction.
So it's about knowing that you aren't limited to just one box on the diagram. You can and should wire the boxes together to use the right tool for the right job.
Integration is the key to sophisticated architecture.
Okay, this is fantastic. We have the theory, we have the parts list, we have the patterns. Now for section 5, The source explicitly tells the reader, the architect, to sketch 2 or 3 reference architectures.
I love this part of the source. This is how you actually learn. This is how you internalize it.
We're going to do this audibly. We're going to audio sketch. I want you, the listener, to visualize a whiteboard. The source suggests 3 common scenarios: chatbot over internal documents, a code assistant, and a summarization pipeline. Let's tackle them one by one.
Let's do it. I've got my virtual marker ready.
Scenario A, the chatbot over internal documents. This is probably the most common request a company has right now. I have 1,000 PDF manuals and HR policies sitting on a server. I want our employees to be able to ask questions about them. Expert, grab the marker. What does this look like on the whiteboard?
Okay, drawing on the board now. On the far left, I'm drawing a stick figure, the user. On the far right, a big box representing the AWS cloud. First, we need the documents themselves. So inside the cloud, the first component I'm drawing is a bucket icon, Amazon S3. That's where our PDFs and Word docs live.
Step 1, data storage.
Step 1. Now, the model can't just read 1,000 PDFs from S3 in real time every time a question is asked. It would be way too slow and expensive. We need to pre-process and index them. So I am drawing a box right next to S3 and labeling it Bedrock Knowledge Base.
The managed storage service we talked about.
Exactly. I'm drawing an arrow from S3 into the knowledge base. Now, that knowledge base needs a place to store the embeddings, the math vectors it creates from the documents. So connected to the knowledge base, I'll draw a little cylinder icon for our vector store. Let's say we use Amazon OpenSearch Serverless for this.
So the knowledge base reads from S3 and writes the index to OpenSearch.
Perfect. Now we need the brain. I'll draw a bigger central box labeled Amazon Bedrock. This is where our chosen model, like Claude 3, lives. I'll draw a two-way arrow between the user's application and Bedrock. When the user asks a question, the arrow goes from the app to Bedrock. Bedrock's built-in knowledge base feature then automatically reaches out to the OpenSearch vector store, pulls the most relevant chunks of text, adds them to the prompt, and generates the final answer.
What's missing?
One last thing. For a good user experience, I'd probably stick a small database on the side. Let's draw the DynamoDB icon. We'll use this to store the chat history so the user can ask follow-up questions like, tell me more about that, and the bot knows what that refers to.
So the final stack is S3 for storage, OpenSearch is the vector index, Bedrock with a knowledge base is the brain and orchestrator, and DynamoDB for conversation memory.
That is a classic, robust, scalable RA architecture. It is the Honda Civic of enterprise AI architectures. It just works, it's reliable, and it will get you where you need to go.
Love it. Okay, wipe the board. Scenario B, the code assistant.
Okay. This one is a bit of a trick question from the source material.
How so?
Because you could build this from scratch. You could follow a similar ADGE pattern, put all your code in S3, use a knowledge base to index it, and then use a code-specialized model like Llama 3 or Claude 3 via Bedrock to answer questions about your code base. And that would work. But remember the supporting services section we discussed and the buy versus build decision.
Amazon Q developer.
Exactly. If I am sketching this solution for a client today, my first drawing might just be a single big box that says Amazon Q developer and an arrow pointing to the developer's laptop. Why spend 3 months building a custom code assistant when you can buy a very, very good one off the shelf? However, if the prompt was slightly different, like build a custom code assistant for our proprietary 40-year-old programming language, then we go back to the drawing board.
And what would that look like?
Then it gets complicated. That sketch would probably start with SageMaker to fine-tune an open source model on millions of lines of your weird old code. Then you'd expose that fine-tuned model as a private endpoint. Then maybe you'd use a Bedrock agent to integrate with the developer's IDE and orchestrate calls to that custom SageMaker model. It's a much more complex and expensive picture, but 99% of the time for a code assistant, just use Q.
That's a fantastic lesson. The blueprint isn't just about knowing how to connect all the parts. It's also about knowing when the part is already fully assembled for you.
Efficiency first. Don't reinvent the wheel unless you genuinely need a custom wheel that doesn't exist yet.
Okay, fantastic. Last one. Scenario C, the summarization pipeline. This is different. This isn't a conversational chatbot. The use case is every time a new call transcript lands in a folder, I want a one-paragraph summary of it stored in a database and emailed to me.
Okay, this is a great one because it's an asynchronous, event-driven workflow. So the sketch starts, again, with S3. The transcript file lands in the S3 bucket. That plop sound of the file landing triggers an S3 event notification. I'm drawing an arrow from that event to a small lambda-shaped icon, an AWS Lambda function. This is a bit of serverless code that wakes up and runs only when that new file appears.
So no server sitting around waiting.
None at all. The Lambda function's code is simple.
Yeah.
Step 1, grab the text from the new file. Step 2, send that text to Amazon Bedrock. The prompt is very straightforward. Summarize this text in under 150 words. Bedrock does its thing and spits back the summary text.
And where does that summary go?
The Lambda function takes that summary and does two things. I'll draw two arrows coming out of the Lambda. One arrow points to DynamoDB, where it writes the summary to a table, maybe for a future dashboard. The other arrow points to Amazon SNS, Simple Notification Service, which is configured to send that summary in an email to a distribution list.
So the flow is S3 triggers Lambda, Lambda calls Bedrock, Lambda writes the result to DynamoDB and SNS.
Clean, simple, fully serverless. No vector database needed, no complex agents, no chat history, just a straight input-output data processing pipe.
Seeing these sketches really helps. It takes that abstract list of services we talked about and turns them into a story, a logical flow.
And that is the why of sketching. The source says this helps internalize the selection process. When you physically draw the boxes and arrows, you realize, oh wait, I need a database here to store the results. Or, wait, Bedrock doesn't store state, so I need to add DynamoDB for chat history. It exposes the gaps in your thinking before you write a single line of code.
It turns the big, messy Lego set into a clear model kit with instructions.
Exactly. You see how the pieces are meant to connect.
So we've traveled from the bedrock of the cloud all the way up to the finished architectural building.
It has been quite a journey.
Let's just quickly recap what we've covered in this deep dive for everyone. We started with Amazon Bedrock at the absolute center. It's the API layer, the secure access point to a whole catalog of models, text, image, and the all-important embeddings, where you should start. We then looked at the Great Divide. Bedrock is for consumption. SageMaker is for custom training and construction. If you can rent the car, use Bedrock. Only if you have to build the engine from scratch do you go to SageMaker.
A critical distinction.
We met the supporting cast. Aurora and OpenSearch for vector search, Kendra for enterprise search, and the workhorses S3 and DynamoDB for raw data and state management. They provide the context and the memory for the brain.
Yep, the whole ecosystem.
And finally, we just sketched out the patterns. RAG for question answering, agents for taking action, and simple direct pipelines for data processing.
The takeaway here, and it's worth reiterating the overview note from the source one last time, is about making this feel like natural selection.
Natural selection.
Not biological selection, service selection. The goal of internalizing this blueprint is that when you, as an architect, hear a business problem like, I need to search my documents, your brain instantly and naturally fires the synapse for knowledge base and RAG.
It's a reflex.
It's a reflex. When you hear, I need to train a model on a brand new proprietary type of data, your brain fires SageMaker. It shouldn't be a struggle. It shouldn't be a 20-page decision document. For 90% of cases, the choice should be an instinct.
And I think after this conversation, we're a lot closer to having that instinct.
I think so too.
Now, as we wrap up, here's a final provocative thought for you to take away. We've been talking about the Bedrock blueprint. We've seen how Bedrock is positioned as this central hub, this orchestration layer connecting data, models, agents, and users. If Bedrock handles the model access, and Bedrock agents handle the business logic, and Bedrock knowledge bases handle the data retrieval.
I see where you're going with this.
Does the role of the AI architect fundamentally change? Does it become less about artificial intelligence and much more about digital plumbing? Are we, the builders, just becoming really good at connecting pipes to and from Bedrock? Is the future of AI development just better plumbing?
That is the billion-dollar question, isn't it? I would argue two things. First, plumbing is what makes civilization work. You don't think about the pipes in your house until they leak or the water stops.
That's a point.
If we can make AI as reliable and as invisible as good plumbing, that's a massive victory. But to your point, yes, the deep science part is moving to the model providers, the Anthropics and Amazons of the world. The engineering part for us is absolutely moving to integration. The architect is the one who knows how to design the system of pipes to make the water flow exactly where it needs to at the right pressure without leaks.
The architect as the master plumber. I kind of like it.
It's an honorable and incredibly valuable profession.
So for everyone listening, we want you to try this. Go to a whiteboard or just grab a piece of paper or the back of a napkin. Sketch an architecture. Think of a simple problem. A recipe generator based on ingredients I have, or a legal contract analyzer that finds the liability clause. And draw the boxes. S3. Bedrock. Dynamo. See if you can make it flow.
Sketching is understanding. It's the best way to learn.
Thanks for diving in with us. We'll see you on the next one.
Goodbye, everyone.